Solving 8.4, Solving Multi-Step Inequalities, Part 1.
Section 8.4, since 8.1 was learning how to write and graph inequalities, 8.2 was your addition and subtraction skills, 8.3 was multiplication and division. Now in 8.4 they're going to throw it all in together and say solve multi-step inequalities. So we're going to try to figure out how we use all of the multi-steps to isolate variables. So you can see now we have a two-step inequality. All the other problems we've been doing are one step. So now they threw in two operations in one. So we're going to rewrite the original problem. It says solve the inequality. So that means we're going to use our inverse operations to isolate the variable. And then once it's the variable is isolated, we're going to graph the solution on our number line. So looking at this, it looks very similar to an equation. The only difference in solving an equation and an inequality, two of them. I shouldn't say only, there's two differences. We graph the solutions on a number line for inequalities. We don't do that with equations. And the most important thing to remember in the solving process is that if we multiply or divide both sides of our inequality by the same negative number, we need to reverse the direction of the sign. So it's that one additional thought process we have to do for inequalities about solving. So in this case, I have to get rid of my constant first, add or subtract the constant term. So in this case, I'm adding. So I'm going to add 4 to both sides of the inequality. So I get 5x is greater than 15, and then I'm going to divide by 5. Since I'm dividing the inequality by the same positive number, I don't need to touch that sign. So x is greater than 3. Set up my number line since my variable is isolated. Let's do 5, and then this would be 1. Place your boundary point at 3. It says all the solutions are greater than 3, so I'm going to shade right. Does it say 3 is included? It doesn't, so I'm going to leave 3 unshaded. Correct answer, x is greater than 3, and then my shaded region is here. If you choose a number from your shaded region and sub it in, so if I'm going to choose 5, I'm going to check to make sure I shaded the correct region. So I'm going to plug 5 into the original inequality and quickly isolate. So 25 minus 4 is greater than 11. 21 is greater than 11. Since it's a true statement, I know 5 should be in the shaded region, and I shaded the correct way. Let's do the second one, which is B. So I get y divided by negative 6 plus 7 is less than or equal to 9. Again, it's a two-step inequality in this case. Add or subtract the constant term first. In this case, I'm going to subtract it from both sides of the inequality using inverse operations. So I'm going to move over here. I get y divided by negative 6 is less than or equal to 2. So I'm going to write it up here just so I have a little room. Now I have to deal with the coefficient. In this case, the coefficient is negative. Red flag in your brain. So when you're multiplying both sides of your inequality by a negative number, what do we need to do? We need to remember to reverse the direction of the sign. So that direction is going to be reversed. Negative 6y divided by negative 6 leaves me a single y, which we just write 1y, is, now you flipped it, greater than or equal to now. Negative 6 times 2 is negative 12. So that means my solutions are all greater than negative 12. Setting up my number line, here's negative 12, negative 11, negative 10, negative 13, negative 14, boundary point at negative 12, and which way do I shade? The solutions are greater, so I'm going to shade to the right. And 12 has an equal to, so I need to shade that as well in my shaded solution set. So negative 12 boundary point and all terms greater or values greater than that are part of this solution set. Quickly, let's check. So pick a number in there. In there is a 0. So I'm just going to choose that. So I'm going to take the original inequality and I'm going to use 0. Even though I don't see it on this section of the number line, I know it exists down here and it's in the shaded region. So I'm going to plug that in and I'm going to see if 0 makes the original inequality true. 0 divided by negative 6 is just 0. And then 0 plus 7 is 7. So does 0 make the inequality true? And yes, it does. 7 is less than or equal to 9. So since 0 made the original inequality true, it must be in my shaded solution set, and it is, because I chose all the numbers greater than or equal to negative 12, and 0 is in that shaded region. So that's what you're going to do right now. It's multi-step. We're going to start with 2 steps, And then we'll go on to distributive property, combining like terms, variables on both sides. Everything we did with equations, we can now do with inequalities. Here's your checkpoint for our part A. It says solve the inequality, graph the solution. So you're going to isolate the variable, then you're going to take that solution and graph the solution set on a number line. 4b minus 1 is less than 7. 8 plus 9c is greater than or equal to negative 28. And n divided by negative 2 plus 11 is greater than 12. Go through the process and then we'll pick right up on the standardized test practice at the bottom.